Compound inequalities are inequalities joined by the words and or. Inequalities joined by the word and mean that solutions must satisfy both conditions. For example, if we say x is greater than 2 and x is less than 5, we are looking for values of x that are both greater than 2 and less than 5. If we look at this on a number line, numbers that are greater than 2 look like this, and numbers that are less than 5 look like this. Numbers that are both are places where these overlap in this region here. So the solutions would be any numbers that are between 2 and 5. However, since it says greater than 2 and less than 5, we would not include 2 and 5 in the solution set. We depict this on a number line by using the open circle. We do this in interval notation by using parentheses. Inequalities joined by the word or mean that solutions must satisfy either or both conditions. If we take a similar problem, but say x is less than 2 or x is greater than 5, we need to look for solutions that satisfy either one of these inequalities or both. In this case, there are no solutions that satisfy both. Numbers less than 2 look like this, and numbers greater than 5 look like this. There's no overlap here, but since this says or, that's okay. In interval notation, that looks like this: negative infinity to 2, and then we use this symbol for union, 5 to infinity. This example is an or inequality. To solve this, we can simply solve both equations and then explore the numbers for the solution set. In this case, we'll add 1 to both sides of the inequality and then divide by 4. So one of our conditions is x is greater than or equal to 3 over 4. For this one, we will subtract 2, giving us negative 3x is greater than 3. Here, we have to divide by negative 3. Remember that in an inequality, when you divide by a negative, you must flip the inequality. So we have x is less than negative 1. So we're looking for solutions that are greater than or equal to 3 over 4 or less than negative 1. In this case, this looks similar to what we just did. Less than negative 1 and greater than 3 over 4 don't have any places where they overlap, but since this says or, that's okay. We only need our solutions to satisfy one or both equations. Numbers less than negative 1 will satisfy this inequality. Numbers greater than 3 over 4 will satisfy this first one. In interval notation, we can write this as negative infinity to negative 1 union 3 over 4 to infinity. Remember, here you always use parentheses around infinity or negative infinity, and always parentheses when it's a greater than. So this should be a bracket. Okay, square brackets when it's equal to. And that should be a closed circle. This is another or inequality. Here we can subtract 1 from both sides and divide by 2, giving us x is less than 3. In this case, we'll add 4. Again, we're dividing by -5. So let's make sure that we flip this to now less than -2. So we're looking for solutions that are either less than 3 or less than -2. This is a little bit different than the previous example because in this case, both inequalities are pointing in the same direction. If we write these right above the number line, just to get a look at the solutions, we have this. Here are the numbers less than 3, and here are the numbers less than -2. Remember, since this is OR, we're looking for anywhere where it would satisfy either one or both inequalities. Here would satisfy both. Numbers less than -2 are both less than 3 and also less than -2. Remember, with an OR, they don't have to satisfy both, but they can. In this case, in this region, the numbers between -2 and 3, we still consider these solutions because they are less than 3 and they satisfy this. Because it's OR, they don't have to satisfy both. The only place we don't have solutions is greater than 3. Greater than or equal to 3. So, because this is an OR, our solution set here is just x is less than 3. Remember, even though there would be an open circle around -2, -2 is still a solution because it's less than 3 and it only has to satisfy one inequality. So we get a slightly different looking answer here due to the fact that these both ended up pointing the same way. So in this case, our solution is -∞ to 3. One more OR inequality. In this case, all we have to do is add 3 to both sides, giving us x is greater than 5. In this case, we'll subtract 6 and divide by 2. So we have x is greater than 5 or x is less than 7. Again, let's take a look at this on a number line so we can really get an idea of what the solutions look like. In this case, numbers greater than 5 and numbers less than 7 have places where they overlap. This looks similar to how we drew the AND inequality in the beginning. There's places where they overlap, then there's places where there's solutions to only one. However, since this is OR, remember that we can have solutions anywhere as long as they satisfy one of the inequalities. Here's both. Here are solutions that only satisfy x is less than 7. Here are solutions that only satisfy x is greater than 5. Since this is OR, the entire real number line will satisfy at least one of these inequalities. So in this case, our solution is all real numbers. Or in interval notation, -∞ to infinity. This inequality is an AND inequality. It's written as an interval, but what this inequality means is -3 is less than or equal to x minus 5, and x minus 5 is less than 8. We can solve this as a split up inequality, but we're also able to solve this by leaving it exactly like this and just solving both inequalities at once. To solve this, we would add 5 to get x by itself, so we can do the same thing to both these places. This will give us 2 is less than or equal to x is less than 13. And this is our solution. We can graph it on a number line, but this already basically describes where our solutions are. This tells us that our solutions are between 2 and 13, including 2 because of the equals to here, and not including 13 because it's just less than. We can go straight to writing this in interval notation, bracket around the 2 because it's equal to, and parentheses around the 13 because that did not have the equals to sign. This AND inequality is already split up, so we can solve this similar to the way we solved the OR inequalities, by solving both. We'll subtract 3 from both sides. Again, here we're going to divide by -2, which means we need to make sure that we flip this to less than or equal to. So one of our inequalities is x is less than or equal to -1/2. In this case, all we have to do is add 4, giving us x is less than or equal to 6. So we have x is less than or equal to -1/2 and x is less than or equal to 6. This is similar to the or inequality where they were pointing in the same direction. But this one is and. So we have to remember that solutions have to satisfy both inequalities. So numbers that are less than or equal to -1/2 would look something like this. Numbers that are less than or equal to 6 would be here. Remember that this is and, so we were looking for places where the numbers will satisfy both. If we look at less than 6, the region between -1/2 and 6 would only satisfy x is less than or equal to 6 and not x is less than or equal to -1/2. They overlap in this region. So our solutions to this inequality would be all numbers less than or equal to -1/2. In interval notation, that looks like this: -infinity to -1/2. Remember a bracket around the -1/2 since it's equal to. This and inequality is also split up. When we solve this one, we'll subtract 3 from both sides, giving us -5x is greater than 3. Again, we're dividing by a negative here, which gives us x is less than -3/5. Here, we'll add 1 to both sides, divide by 2, and we get x is greater than 3. So our two inequalities are x is less than -3/5 and x is greater than 3. Solutions in an and inequality must satisfy both. When we look at this on a number line, numbers less than -3/5 and numbers greater than 3 do not have any overlap. There are no numbers that are both less than -3/5 and greater than 3. This means that this compound inequality has no solution. You can either write no solution or you can write the symbol for the empty set, which means the solution is the set of no elements. No numbers will satisfy both of these inequalities.